Last week we were talking about biomes, and in this illustration you can see one of the reasons for why biomes have the distributions that they do. Here are those air cells we were talking about, the Hadley cells, Farrell cells, and Puller cells. What sets these cells up is the movement of air as a consequence of heating at the surface, and you can see that illustrated here. At the equator, the surface of the Earth is warmed, the air warms, and it rises. As it rises, it cools. As it cools, its ability to hold moisture decreases, and therefore it rains, so all the moisture is lost. That air is now cold and dry, spreads out both north and south. That cold, dry air now is going to be moving, always replaced from below, and then ultimately falls. And as it falls, you can see that at the junction between the Hadley and the Farrell cells, as it falls, it warms. As it warms, its ability to hold moisture increases, and then as it comes closer to the surface, it picks up all the moisture from the surface, and that, of course, is why we have deserts at 30 degrees north and 30 degrees south. The next thing to keep in mind is both east, west, and north-south slope effects. The east slope is generally more lush in vegetation than is the west slope, and that's simply because once the sun is up, the rays of the sun are warming the east-facing slope, but it's in the morning, it's relatively cool. So all of the warming takes place in the cool part of the day. Once the sun goes past its zenith and it's now in the afternoon, it's been warming up all day, so the air around the west-facing slope has been warmed all day long, even though it wasn't in the direct sun. And now in the warmest part of the day, it's receiving all of the direct sunlight, and as a result, it's going to be much hotter and much drier on the west slope than it is on the east slope. You can see that illustrated here. This is an east-west slope effect. You see all the nice lush conifer trees there. They are on the east-facing slope. The barren areas are on the west-facing slope. And you can see that illustrated here in this drawing for a north-south slope effect. It's the same idea. The north-facing slope gets less direct sunlight and therefore is cooler, has more moisture and more lush vegetation than the south-facing slope.